And today I will present my individual project, the Adaptive Climate Learning Hub, designed for the Warlpiri community in Endemo. This project responds to an educational emergency caused by extreme heat, strong sunlight, and the lack of comfortable outdoor learning spaces. First, it's about my background and emergency scenario. Endemo is a remote desert community that experiences very hot, dry conditions with temperatures frequently rising above 40 degrees, as shown on my PowerPoint. And harsh sunlight, UV exposure, and heat stress reduce learners' concentration and limit the time they can safely spend outdoors. Warlpiri young people often prefer outdoor learning, but the existing spaces offer limited shade, ventilation, or climate protection. This creates an educational risk because discomfort directly interrupts participation and learning continuity. My aim was to design a small-scale learning hub that improves comfort using simple, low-maintenance, and climate-responsive strategies. Then it's about my research insights. First, it's about my secondary research. My secondary research highlighted two key insights. First, climate research shows that desert architecture relies on passive design, shading, roof ventilation, and natural airflow to reduce heat. Then it's about indigenous learning studies explain that the Warlpiri education is relational, mobile, and connected to country. Learners need open, flexible spaces rather than enclosed rooms. This insight guided me project. The hub needed to use natural environment process while supporting culturally preferred outdoor learning. I also reviewed research on solar energy systems, which are reliable for remote communities with limited infrastructure. This led me to integrate a small solar panel into the prototype. Then it's about my primary research. My primary research focused on two main areas. First, testing the LDR light sensor. I used an Arduino LDR and a 10,000 ohmic resistor to observe how the sensor responded to different light levels. This test helped me understand how the hub could detect strong sunlight and provide a simple feedback signal using an LED. And then it's about exploring spatial form and shading. I built cardboard models to study roof angles, opening size, shading performance, and the relationship between height and exposure. These models allowed me to visually analyze how the structure could reduce glare and guide airflow without mechanical cooling. Even though I did not run airflow experiments, the spatial modeling helped me understand how roof geometry and openings could naturally support ventilation. Then it's about my iteration process. My iteration 1 focused on conceptual exploration. I produced over 30 sketches exploring different roof shapes, wind positions, and shading systems. These early drawings helped me identify which forms were most suitable for desert conditions and Warlpiri learning preferences. And my iteration 2 integrated electronics and structure. I tested the LDR LED system, explored wind angles, and added a roof-mounted solar panel. This iteration confirms that a passive system supported by minimal electronics was the most reliable and culturally appropriate choice. I combined the ideas of later sketches directly into the final prototype, keeping the system simple and maintainable. And this is my final prototype. As shown on page 8 of my PowerPoint, the final hub includes a pitched roof that channels heat upward, and high and low openings that support natural ventilation, and a solar power LDR that detects sunlight intensity, and an LED that acts as a subtle indicator for strong sunlight, and a fully off-grid electrical system powered by a mini solar panel. This structure stays open and breathable, aligning with Warlpiri learning culture while improving comfort in extreme weather. Then it's about my community impact. First is improves outdoor learning comfort and supports indigenous learning preferences and cultural practice and increase participation and focus and low cost, maintainable and suitable for remote communities and climate responsive and environmentally sustainable. And then is solar power enhances sustainability and local adaptation. Finally, about my reflection. Through this project, I learned that effective design in remote communities must balance environmental logic, cultural appropriateness, and low-tech innovation. Instead of relying on mechanical systems, I focused on natural processes, shade, airflow, and solar energy to create a learning space that is simple, respectful, and realistic.